Okay, we're going to come back here with Chapter 4 of Geotech Engineering, homework problem 8. And note I added a word here, saturated, and I'll make sure you know about that because that's going to make it a little easier to solve our phase diagram. If the unit weight of a 1 cubic foot saturated soil sample is 126 pounds per cubic foot, and its dry unit weight is 102.3 pounds per cubic foot, complete a phase diagram worksheet and solve for the water content. So I went ahead and started with our default values here, that our weight of air is 0, our gamma air is 0, and our gamma water is 62.4 pounds per cubic foot, and went ahead and wrote them into the phase diagram worksheet. From here, I'll go ahead and list what we were given in our problem. We're told that the unit weight of the 1 cubic foot soil sample is 126 pounds per cubic foot. I'm going to go ahead and write the volume down because it says it's a 1 cubic foot soil sample, and that's the total volume. So I'm going to make that my number 4, and I'll put that down here, and then I'll duplicate it right next door for number 5. But then I also was told that the unit weight is 126 pounds per cubic foot. So I'll go ahead and put that in too. And I'll put that in as number 6 here. Okay. So I've got a good start here. When I look at that, I can already see that I'm going to be able to find out the total weight. So I'm just going to go ahead and do that because I know from this top relation here that the total volume times the unit weight, total unit weight, is going to give me the total weight. So I'm going to go ahead and use that relationship and to compute the total weight. And that's just 1 times 126, 1 cubic foot, times 126 pounds per cubic foot. So that's just 126 pounds because my cubic feet will cancel out. So I'll add that here for number 7. All right, I've got that whole bottom row filled out. Let's go back to the original statement of the problem. The other thing we know is that it's saturated, and we also know the dry unit weight. So I'm going to use the dry unit weight next. We've talked about that before, sometimes called dry density in these problems. The gamma D is 102.3 pounds per cubic foot. I remember from my phase chart diagram that relationship, gamma D, is really that ratio of the weight of the solids to the total volume. And happily here, I know the total volume. So if I multiply both sides by that total volume, I can find my weight of the solids. So volume times gamma D is going to give me the weight of the solids. In this case, my total volume is 1. And I said 1 cubic foot. My gamma D is 102.3 pounds per cubic feet. So my weight, that's going to be my weight of the solids. So my weight of the solids is just, again, easy math, 102.3 pounds. And so I'll put that in my phase diagram here for number 8. Will be 102.3 pounds. Okay, so that's the information that I was given initially, and this is why you can see I needed to know about that saturated soil sample. But we can figure out the weight of the water here. So let's go ahead and do that before we even talk about the saturation. I know if I add up this column, I'm going to add them up to get this total weight. So I'll be able to figure out the weight of the water here. So let's go ahead and do that. The weight of the water plus the weight of the air plus the weight of the solids is going to give me my total weight. Remember, my weight of the air is always going to be 0. So it's really just these two things that I'm adding up. In this case, I want to find the weight of the solids, so I'll just take that total weight and subtract the weight of the solids. So it's just 126 pounds minus 102.3 pounds is going to give me the weight of the water. And in this case, slide that down a little bit more. I'm going to have that 126 minus 102.3, and that's 23.7 pounds. So we'll fill that in here for number 9, 23.7 pounds. Okay, I could find the volume of water without using that saturation information, so I'll go ahead and do that next for number 10. Because again, going straight across, I know that the volume of water times gamma water is going to equal the weight of the water. In this case, I know gamma and I know W, so I'm looking for V. So I'm going to divide both sides by that unit weight of water. So my volume of water is going to equal the weight of water over gamma water. And in that case, these numbers, take a look at our work here, it's 23.7 pounds divided by 62.4 pounds per cubic foot, which is going to be equal to something pretty small, 23.7 divided by 23.7 divided by 62.4. Yes, a pretty small number. And remember, for volume, I'm going to take it to 2 decimal places. So I'm going to call that 0.38. So that's 0.38. My pounds will cancel. My units, they're in the denominator of the denominator, come up to the numerator. So I have 0.38 cubic feet for volume of water. So that is number 10. Okay, and so if you didn't know that this was 100% saturated, that's as far as you were going to be able to get on this problem, because once you get to this point, remember you can't use that additive relationship here. We don't know enough information to add up these things because we don't know about the voids or the solids, so you're kind of stuck here. But if we add that this sample is 100% saturated, we're going to be able to move on a bit. So let's go ahead and do that. Slide this under here. Slide that over just a little bit more. Okay, so let's start off then with number 11. And we'll go with the fact that this is a 100% saturated soil sample. So my SR is equal to 1. And remember from my table that the saturation, that my volume of the voids is equal to my my volume of the water. Okay, every void is filled with water. Okay, and that does help me here because I know my volume of water, so my volume of voids has got to be equal to that. So my volume of the voids has got to be equal to 0.38 cubic feet. So I'll use that for my number 11, 0.38. Now you also can remember that if all my voids are filled with water, that means that my air has got to be 0. So either way, that could have been your 11 or your 12, but my volume of air has to be 0 there. I'm going to make that my number 12. And I'll just say since this SR is equal to 1. Or you could say volume of voids equals volume of air plus volume of water. Okay, and if volume of voids equals volume of water, volume of air equals 0. So a couple different ways you could justify that. All right, so once we know that, we can find this volume of the solids. Let's go ahead and do that. Just looking at our straight down math, you could either use this column or this column, same thing. This one's a little bit easier since we don't have that 0 to put in there. So I'll just say the volume of the voids plus the volume of the solids is going to equal the total volume. So I'm going to take that 1 cubic foot and I'm going to subtract the 0.38 cubic feet. and that's going to give me my volume of the solids. And let's go ahead and do that. 1 minus 0.62 cubic feet. And that's 0.62, and then I'm just going to duplicate it over here. Then that will be my 14. All right, I'm just about there. And remember, for these steps on your final exam, you're going to have to justify and show me how you got those values. So, to say VA equals 0, yes, that's true, but why is that true? So either one of these justifications would be fine since the saturation rate is 1, or you can go through that additive process since we had those values for this one. Okay, let's find our last thing, gamma solids. And remembering our relationships, gamma solids is going to equal the weight of the solids over the volume of the solids. And in this case, yeah, I know both of those values, so let's go ahead and plug those in. 102.3 pounds over 0.62 cubic feet. And we'll go ahead and put those in here. 102.3 divided by 0.62, and I get 165. Nice round number, 165, and then my units just come right off of there, pounds per cubic foot. And that will be my number 15, 165. All right, so we have all our steps. We've got our phase diagram worksheet all filled out. You can double check it, adding up the columns, multiplying across. On our initial, then go back and check your initial problem, make sure you solved for everything we had to solve for. The only thing we didn't find is the water content, so let's go ahead and solve for that. I'll just put that at the bottom here. The water content, again from our phase relationships, it's just going to be that weight of the water over the weight of the solids, and in this case, that's find your weight of the water, 23.7 pounds, divided by 102.3 pounds. So it's just that ratio. So I'll put that into the calculator, 23.7 divided by 102.3. And we can multiply that by 100. It's usually expressed as a percent and a whole number percent. So that's just 23%. And that way we've solved everything for homework problem 8, phase diagram, and our water content. And I didn't go back and forth as much on this problem to show you all the relationships. I'm hoping you're getting a little bit more comfortable with those and don't even need to look them up as much. But remember, those relationships will be available to you on the final exam.